Greetings, and welcome back to PBH 275, Injury Prevention and Control. Today's module is about fire, a persistent injury issue here in the United States, and also a major source of injuries and deaths in many rapidly industrializing and developing areas of the world. The objectives of today's module include the following. We're going to talk about the dynamics of fire. What is fire exactly, and how is it created? We'll also talk about the scope of fire's contribution to human and community injury, both currently and also historically. We'll talk about the various types of risk factors for fire injury, and then we will talk about prevention strategies. Now, the prevention strategies we're going to talk about are going to primarily be focused at the primary and secondary level. If we can stop fires from ever occurring and nobody gets injured by fire, that's great. Sometimes fires cannot necessarily be prevented, and that's where secondary strategies come in, making fire events much more survivable through quickly putting them out, through rapid evacuation, from things like that. I'm not really going to talk about tertiary measures very much in this lecture. Having a good burn unit in every community would be a wonderful thing to have, but fire injuries are so painful, they're so debilitating that we really, as public health minded people, need to put all of our focus on making sure nobody ever gets these severe burn injuries. I mean, it's good for rehabilitation and medical treatment to be available for those, but if we just stop those things from happening, that's where our focus is, and that's where the focus is going to be in this module. Let's start with a quick overview of what exactly is fire. The information I'm about to present comes from the Northwest Fire Science Consortium, and you can see the URL link here on the page. This is a really good source of concise information, really explains fire in a very effective manner. So what is fire? Well, fire is the visible part of a chemical reaction that results in the combustion of materials. In other words, materials go through this combustion process, which is essentially a chemical change process. The materials change forms. You start off with one type of material, and you end up with a different type of material. In this case, you might wind up with ashes and embers, and some of the solid material actually being converted into gases. So that's the chemical reaction. It results in combustion of materials, and fire is the visible part of that chemical reaction. In order for a fire to occur, three things have to come together in space and time: oxygen, a source of fuel, and a source of heat. That's why we call that the fire triangle. You can also envision it as three legs of a stool, where if you take one leg off, the stool falls over. And it's kind of the same concept with the fire triangle. You need oxygen, fuel, and heat in order for a fire to start, and once a fire is started, you need all three of those things for the fire to continue to propagate and grow. This means that all three legs of the fire triangle can be targets for fire prevention, as we'll talk about in this lecture. The first of the three legs of the fire triangle that we will discuss is oxygen. For a combustion process to occur, you have to have a minimum of 16% oxygen in the environment in order for a fire to start or propagate. That's sort of the minimum baseline level. Now, our atmosphere at sea level and standard temperature and pressure is 20.9% oxygen. So therefore, there's usually more than enough oxygen in the environment to start and propagate fires. It's only when you get into incredibly high altitudes in places where people struggle to live because of the low oxygen content of the air that you also would have a similar problem with fires not being able to propagate very well. And fires also don't burn optimally if the atmosphere is too rich of oxygen. Once you get above about 23 or 24% oxygen, that can be too rich of an environment, and fires don't propagate very well there either. But at the atmospheric oxygen we normally have, fires can start and propagate. So it is logical to think then that one way to put out fires would be to use fire suppressants that remove oxygen from the areas where a fire is occurring. And yes, that does work. This happens in indoor environments sometimes when you're talking about delicate equipment rooms such as server rooms where maybe if a fire starts, you don't want the sprinklers to go off and saturate the equipment because that will cause an unacceptable level of damage to the equipment, and also it might not put out the fire quickly enough. In those cases, you can actually use an extinguishment system that will push the oxygen out and suffocate the fire. The obvious disadvantage with these systems is that if people are in the area, they need to be given lots of advance warning so they can evacuate, because if an atmosphere will not support a fire, it also will not support human life. And if a person passes out and asphyxiates because of the fire suppression systems that push the oxygen out of a room before they can escape, that's not an outcome we want either. So there are very limited uses for fire suppressants that can remove oxygen, but there are some. Fires cannot exist in the absence of a material that is capable of burning. Materials capable of burning are also known as combustible materials, or in the parlance of the fire triangle, as fuel. Now, the ability of a fuel to propagate a fire depends on a lot of different factors, one of them being the moisture content of the fuel. For a lot of the wildfires that happen here in the western U.S., trees and shrubs are a very common fuel for the fire. Well, when the trees and shrubs have high moisture content, they're less likely to propagate a fire. During severe drought conditions, when the trees and shrubs do not have a particularly high moisture content, they can catch on fire much quicker. The ability for a fuel to propagate also depends on its shape, size, quantity, and its ignition temperature. As we'll talk about in the next slide, any source of fuel is not going to catch on fire until it is heated above its ignition temperature. At that point, it will start to catch on fire. Below that point, it will not catch on fire. There are some materials, such as plastics, that we don't think of as being readily flammable, but they are combustible, meaning that if you keep heating them and keep heating them, they eventually reach a point where their ignition temperature is exceeded and they start to burn. That plastic will start to change forms. It will become ash and ember, and it will put off in a lot of cases, toxic gases. There are many possible sources of fuel for fires in our lives, things that can propagate a fire in the source of sufficient oxygen and being heated above their ignition temperature. This includes trees and shrubs. Certainly that's a big fuel for fire. Houses themselves can be fuel for fire, particularly when they're built of relatively combustible materials such as wood. A lot of houses, even if they have masonry and drywall on the outsides of them, they might have joists and trusses made of wood, and those can function as a fuel for a fire readily. Some houses have directly flammable liquids and gases stored in them, particularly in garage areas, and things such as grease, which, whether it's stored in a garage or present in a kitchen, can be a great source of fuel for a fire. And as I talked about before, plastics, when heated above their ignition temperature, become a source of fuel for propagating a fire. The third leg of the fire triangle is heat. A combustion process cannot occur unless fuels are present and then heated to above their ignition temperature in the presence of sufficient oxygen. Once that happens, then you have a fire. After that initial ignition, heat is also required to maintain and propagate a fire. Because what heat does is it will, especially if you're talking about the fire itself, the leading edge of a fire will put off a lot of heat, which will remove moisture from nearby fuel, therefore lowering the ignition temperature of the nearby fuel so it can catch on fire more easily. And it will warm the surrounding air and preheat the fuel in the fire's path. This is part of the reason why sometimes when firefighters and other people who have battled fires talk about fires, they kind of talk about them like a living thing. It's like fires are essentially feeding themselves because the heat that they're putting out is actually making it easier for the fire to keep on going because of what it's doing to the fuel around it. Now, the fire itself doesn't always have to be the source of heat. Sometimes incredibly hot climate conditions can be the source of heat that helps remove moisture from fuel and promulgate a fire, but the fire itself can also provide this. So those are the three legs of the fire triangle: oxygen, fuel, heat. Fires require all three legs of the fire triangle to come together in time and in space. They have to be happening at the same time and within a close enough proximity to each other that they all can work together to create the fire. So a key element of fire prevention and fire mitigation is removing, reducing, or separating out one or more of the legs of the fire triangle. Then you don't have a fire. When you go into the CDC WSCARS data system and try to find out how many people die in the United States in a given year due to fire and flame, for the most recent year that data is available, 2023 as at the time of this recording, fire and flame is actually the 13th leading cause of injury death in the United States for that year. So when you dig into the data a little bit closer and look at ideation, what you find is that the vast majority of these almost 4,000 fire and flame deaths that occurred in 2023 were classified as unintentional. There were 98 of them that were classified as homicide, and another 183 that appeared to, after investigation, to have had a suicidal ideation involved in it, and then another 242 fire and flame deaths for which this type of causality and intentionality cannot be determined. When you look at the age-adjusted rates, it's almost exactly 1 per 100,000 deaths due to fire and flame in the United States in the year 2023, and the years of potential life lost, 47,579 during that calendar year. When we look at these fire and flame fatalities, just in their distribution by age, we see a pattern that probably will not surprise you. You see that the rates in the very youngest childhood, from 0 to 9, are a little bit higher than they are in older childhood and then into young adulthood. That's because when children are very young, this is when they are exploring their environment around them, and that's where sometimes playing with fire and playing with matches or other combustible materials can sometimes cause a problem, and they can lead to fatal injuries. And then you'll see that as people get older, the risk gets higher as well. By the time you get into the 80 plus age group, the rate is actually greater than 4 per 100,000. Again, this is because as people get older, they're not as resilient, so that an injury that maybe could have been recoverable when you were younger, you cannot recover from. Plus, there's just things like it's harder to evacuate a house in the event of a fire that starts with a cooking appliance, for example. And sometimes, as people's cognitive abilities weaken as they get older, they forget that they turned the stove on, or things like that are part of the reason why it's so important as people get older to make sure that we protect them from the types of risks that can lead to fire, which can then, if you cannot escape the fire, can lead to a fire-related fatality. When we look at 22 years worth of data from WSCARS, going all the way back to 2001, we can see that the total number of deaths in the U.S. every year has kind of gone anywhere between 2,800 and 4,000 people. Now you see that the population of the U.S. has increased significantly from the year 2001 to the year 2022, and so therefore there have been some improvements in the rate of fatal fire and flame deaths. But still, they're still hovering around 1, and we still are seeing a lot of years of potential life loss, anywhere from 40 to 50,000 every year. Of course, it used to be worse, and 20 years ago it was in the 70s, but still, this is why I entitled this lecture A Persistent Injury Issue, because while some slow progress has been made since 2001, we're still talking about something that claims more than 1 per 100,000 people in the United States every year. And so that's why it's persistent, and we need to do some things better. If you want to know how large of a problem fire and flame are as a source of non-fatal injury in the U.S., you come across a problem you do with a lot of other non-fatal injuries, and that there's a lack of data, because if a person does not interact with the medical care system, then often their injury does not get counted. Now, with that being said, the WSCARS does have a fairly robust system for tracking any logged emergency department visits and having the reasons why the emergency department visit occurred logged with the patient record. And if we look at the year 2023, we see that fire is still a fairly significant source of non-fatal injury here in the United States. Look at the gray boxes. Those are the ones that are of importance here. That's unintentional fire and burn. You see that overall, for all ages, it's the 14th leading cause of non-fatal injury. But then you see, again, a little bit of a gradient based on age, where for those under the age of 1, it's the 7th leading cause of non-fatal emergency department visit injury. And for those 1 to 4, it's the 9th leading cause. And then you see as kids get a little older and people transition to young adulthood, it falls a little bit farther down the chart. It's not in the top 15 in ages 10 to 24, but then from age 25 on all the way through the end of life, it's there as the 15th leading cause of non-fatal injury in the U.S. The other reason why I call fire a persistent injury issue is because it is still such a large global killer. What I want you to see with this map from 2019 is that, well, the United States and many of the other highest gross domestic product countries on Earth have a rate of fire-related deaths of around 1 per 100,000, which is still too many, but that's what their rate's been at for a little while without a lot of significant improvement. There are other parts of the world where that rate is so much higher. In some countries on Earth, that rate is closer to 6 per 100,000 people who die due to fires and burns every year. Particularly if you look at southern Africa, you see that the nations of Zimbabwe and then also Lesotho and Eswatini, and then in the South Pacific, the nation of Papua New Guinea, they have rates that are more than 6 times our rates. And there are reasons for that. Some of it has to do with rapid industrialization and economic development. Some of it has to do with not having as much infrastructure available for secondary prevention, and maybe older buildings, not as much enforcement of building codes, things like that. But if we want to be global injury prevention people, we want to address an issue that's still killing and disabling a lot of people across the world, fires and burns are still a major problem, and it needs to be addressed. And of course, when we address these, we need to bring evidence-based solutions to bear, but also culturally appropriate ones. Now let's go over a few selected fire events that happened in the United States. Obviously, this is not an all-encompassing list, but this is a list of events from which public health and safety and injury prevention-minded people learned a lot of important lessons. And the first one I'm going to talk about goes all the way back to 1871, and that would be the Great Chicago Fire. There's still not complete consensus as to what caused the Great Chicago Fire, though the most common theory is that a cow knocked over a lantern inside a barn, which then ignited some hay and straw inside that barn and rapidly started the fire that ultimately burned about 30% of Chicago and caused around 300 deaths. What we absolutely do know about that time period, and from the photographs and examinations of the area, is that the place where the fire started was a very dense residential area where houses were very close together. They were all made of wood, a quite combustible material, and a lot of them had, to keep snow and water out, had shingles that were made out of tar pitch, which is a petrochemical with a very low ignition temperature, and which readily burns at the slightest provocation. So one of the important lessons that came from the Great Chicago Fire is that it's important to maybe build residential areas of a little bit less density where possible, or when you have high density residential urban development, to use more fire-resistant materials. Use brick and block and sheetrock. Try not to use so much wood and tar pitch and things like that. So there were lessons learned about using more fire-resistant materials for building construction as a result of the Great Chicago Fire. In 1906, there was an earthquake in San Francisco, California. And you're probably wondering, why are we talking about an earthquake? This is the fire lecture. The reason why we're talking about it is because ultimately around 3,000 people died as a result of the San Francisco earthquake. But most of those fatalities were not due to the shaking ground causing buildings or building contents to fall on people. Most of the fatalities were due to fires and explosions. What happened in San Francisco was that once the ground started shaking, a lot of natural gas lines, because a lot of the buildings had piped natural gas into them, natural gas lines started to rupture. And as the natural gas lines ruptured due to the shaking, the friction generated caused the natural gas to ignite, and then you basically had a series of torches burning everything in their path. Or in some cases, if the gas didn't ignite immediately, the leaking gas would fill a room and then ignite all at once and cause a massive explosion. So that's the reason why most of the fatalities occurred in this earthquake. The important lesson that was learned as a result of the San Francisco earthquake is that if you live in an area that is prone to earthquakes, like California, like Alaska, like Nevada, it's really important to have seismic gas shutoff valves. These are valves that in gas lines so that when the ground starts to shake, they automatically close so that gas will not leak in the event that the pipes get ruptured, particularly at the point of operation inside a building, which is where the rupture is most likely to occur. And that can save a lot of lives. And that was the important lesson from the San Francisco earthquake. We talked about the Triangle Shirtwaist Factory fire incident earlier in the semester in the occupational injuries lecture, but it's worth bringing up again because of what it led to. Again, as a reminder, this was a factory fire that occurred in Lower Manhattan, New York in 1911, resulting in 146 deaths. The reason why it resulted in so many deaths is because the fire exits on this 11th floor factory had been chained shut because the owners were worried about employees sneaking merchandise out. So once the fire started and people could not get out, and so many of them died of burns and smoke inhalation. Not a few people also died as a result of smashing open the windows and trying to jump to safety, but again, since they were on the 11th floor, that wound up being a fatal fall. What happened as a result of the Triangle Shirtwaist Factory fire is that the city of New York started a building fire and life safety inspection regime where for every building that had high occupancy, whether occupational or residential, it would be inspected by a city fire marshal. And there would be no chaining of exit doors. There would be no other conditions that would exist that can endanger people to this degree again. And many other places up and down the eastern seaboard, and eventually nationwide, this became the expectation. But the Triangle Shirtwaist Factory fire incident was really the first incident in the U.S. that showed the need for this type of enforcement activity to protect people in their workplaces and in high-rise, high-density residential settings as well. In 1947, in the town of Texas City, Texas, which is on Galveston Bay, just a little bit outside of the city of Houston, there was a cargo vessel that was docked in Texas City that caught on fire. And it started off as a small fire. The problem was the cargo that was on this vessel was 2,300 tons of ammonium nitrate fertilizer. Ammonium nitrate is basically an explosive, and it has a relatively low ignition temperature. So this very small fire and a part of the cargo vessel very quickly ignited this 2,300 tons of ammonium nitrate, which created one of the largest explosions in human history that did not involve atomic power. It sent a massive shock wave and blast and heat wave into the town of Texas City. And as a result of this shock wave from this explosion, many other facilities in Texas City also caught on fire and exploded, including several nearby ships. There was also an oil processing and storage facility very nearby that caught on fire and then exploded as a result of this. When it was all over with, much of Texas City had been destroyed in a series of explosions and fires. 581 people were confirmed dead. And the lesson that was taken from this, that is still applied to this day, is if you're transporting hazardous cargo, whether it's by ship or by plane or on a truck, there are many safeguards that have to be in place to ensure that that does not become a bomb, that in the event of a fire or collision or something like that, that that some basic provisions need to be in place, and those are enforced by the Department of Transportation. There was also a lot of lessons learned about process safety management, particularly if we're talking about the oil handling and storage facility that caught on fire and exploded as a result of, in this case, something that was happening outside of its plant walls that it was vulnerable to. And we'll talk about process safety management in a little bit more detail later in this lecture, but it's the idea that you have to consider everything that can impact your process and that might create ecological hazard or dangers to people. And those all have to be accounted for. And a lot of those lessons were unfortunately brought home why they were so important as a result of Texas City. Right here in the Las Vegas Valley, back in 1980, there was a deadly fire incident in the MGM Grand Hotel Casino. Now, this is not the same MGM Grand that we know today. This location was the one on the corner of Flamingo and Las Vegas Boulevard, the one that's known today as Horseshoe, and was known before that for many years as Bally's. But back in 1980, that was the MGM Grand, and that was the building that caught on fire. There were 85 deaths. Most of them were due to smoke inhalation. What happened was a small fire started off on the first floor in a restaurant delicatessen area. But because this building was not required at the time to have fire sprinklers, it did not have fire sprinklers. And so that small fire was not quickly put out. But most of the deaths were due to smoke inhalation. This building also didn't have smoke barriers between floors because, again, that was not something that was required at the time. So a bunch of smoke from this first floor fire shot up through the stairwells and through the elevator shaft and accumulated in the upper floors where people were staying. And many people staying in these floors were unable to escape before they were overcome by the smoke. And so the important lessons that were learned as a result of the MGM Grand fire is that smoke barriers are critically important on any kind of high-rise, whether it's residential, occupational, entertainment, and hospitality. That you don't want smoke to be able to travel up stairwells, up elevator shafts, and things like that. And so smoke does not quickly spread. It's critically important to have smoke barriers, dedicated escape corridors with 2-hour fire-rated doors on them to give people at least somewhat of a chance to get out before the fire and smoke get too high up the building. And of course, the critical importance of fire sprinkler systems. The MGM Grand fire showed a lot of people the inadequacies of the current laws and regulations, and a lot of the improvements that happened as a result of that were, unfortunately, like many things in public health, due to this tragic event. Moving forward in time a little bit now to the year 2010, off of the coast of Louisiana, about 40 miles into the Gulf of Mexico, there was an oil drilling platform called the Deepwater Horizon. And then on one fateful day, some methane gas started to come up through this well that had been drilled deep into the ground below the water. And there are valves that are supposed to prevent methane from coming up through these wells. They're literally called blowout preventer valves. Well, the blowout preventer valve was not working, and so this methane came rushing up, and then through the force of friction of coming up, the methane gas ignited and then exploded. And very quickly, the entire Deepwater Horizon was on fire and then collapsed into the Gulf of Mexico. There were several dozen workers aboard the Deepwater Horizon when this happened. Many of them were able to escape, but 11 people were never found again and presumed to have died. We also remember the Deepwater Horizon because it was one of the largest ecological disasters in U.S. history. Because for many months after the drilling well platform collapsed into the Gulf, the well continued to spew oil into the Gulf, again for several months, having devastating effects on several aquatic ecosystems. It was also devastating to the fishing and shrimping industries of South Louisiana. The Camp Fire in Paradise, California in 2018 tragically claimed 85 lives. Paradise is a small town in Butte County, a little bit north of Sacramento. Like many places in California, it had been experiencing drought for many years, and so there had been a long-term buildup of dry vegetation in and around Paradise, California. And on the day that this fire broke out, it was a red flag warning day. There were straight line winds that blew over some power lines, and those power lines that were still energized had ignited some vegetation. And then the fire very rapidly spread into Paradise, and people didn't have enough time to evacuate, and ultimately there were 85 deaths. Because of the location of Paradise, at the very edge of the Central Valley, kind of where the Central Valley meets the Sierra Nevada mountains, its topography meant there was not a lot of ways in and out of town, and so this happens a lot of times with very rapidly moving fires. Sometimes the fires knock out many of the paths that you would otherwise take to get out of town and makes evacuation difficult and in some cases impossible. And so the combination of limited ways in and out of town and rapid spread left many people trapped in the fire's path. The fact that Pacific Gas and Electric, or PG&E, had not de-energized the power lines in the neighborhood before this event occurred was another factor that led to this devastating fire. In 2023, a fire event occurred on the island of Maui in Hawaii that bore some very strong similarities to the event that happened in Paradise, California. Most of the 104 deaths as of this recording that have occurred due to what was known as the Maui wildfires occurred in the village of Lahaina on the island of Maui in Hawaii. And like the fire in Paradise, what drove this was climate change. There had been many years of drought and some very dry vegetation. What exacerbated conditions in and around Lahaina was the fact that a lot of invasive species that were not native to Hawaii had either been purposely planted or had been allowed to propagate in this area and had not been managed. And these invasive species created a lot of fuel for potential fires. And then you combine that with drought and straight line winds, and it's also believed that power lines also contributed to this massive fire as well. So this fire had a very rapid onset. It went down into the village of Lahaina before a lot of people could even respond. The civil defense sirens that were supposed to go off also did not go off in a timely manner, and this probably prevented a lot of people from escaping as well. So this trapped a lot of people in the fire's path. Because of its relative recency, the total death count is still not fully known. As of this recording, it was 104. That could change upward or downward. We're now going to talk about structural fires. Human beings tend to spend a lot of time in structures. It's where we live, where a lot of us work, where we go and experience cultural events or sporting events or things like that. And so since structures are often occupied by people, we want to try to avoid structural fires, and they continue to be a major source of injuries and deaths here in the United States, maybe not to the degree they used to be in the early parts of the 20th century. Structural fires are still a major source of injuries and deaths in areas where industrialization and urbanization are rapidly occurring. That makes sense if you think about it. In a lot of rapidly industrializing societies, buildings are going up very quickly and not always with the greatest consideration toward fire safety, being able to escape rapidly, maybe having considerations for things like defensible space or not building things so densely so that fires can't ravage through a community quite so quickly. So as I alluded to before, at the beginning of the 20th century, the 1900s in other words, we had a much higher death rate in the U.S. from structural fires than we do now. But there's still about 3,000 people dying of fires every year in the U.S., and most of these are fires that take place within structures. Not all of them, but many of them are still structural fire deaths. So how have we gotten better here in the U.S. with structural fire deaths? Well, a lot of it's been improvements in building codes. A lot of buildings now are created out of materials that don't burn as readily, that have much higher ignition temperatures. It's a lot harder for a building that has masonry or sheetrock to catch fire than a building that's almost entirely wood or something like that. So There's also been improvements in wiring codes. Electrical fires are not as common as they used to be inside structures. And as I talked about before, with the utilities such as natural gas, making those infrastructures a little bit more robust makes it a lot less likely that those are going to ignite building contents and put people at risk. There's one problem that's only getting worse now, though, and that's particularly here in the western and southwestern United States, and that's wildfires. And yes, wildfires, I talked about them when we talked about Lahaina and Paradise, California, that when a wildfire occurs because of maybe years of certain forestry practices, and maybe exacerbated by drought, by non-native species, by utility infrastructure such as power lines that fail in the event of that fail during windstorms. Wildfires will often spread quickly enough that they start to engage structures as well. A lot of people live in the woods or live on the edge of the woods, and there's whole towns that are located on the edge of the woods, and so very quickly a wildfire can cause a lot of structures to burn as well. In fact, wildfires are now a major cause of structural fires and deaths here in the United States, particularly in the West and Southwest. Historically, some of the greatest fire tragedies that have occurred have been in high-rise residential or occupational buildings because they're often very tall buildings with a high density of occupancy, and if something happens inside that building to ignite some contents, a lot of people can potentially be affected in a very short time. And that's why they can be so dangerous and why so many of these improvements that have happened with smoke barriers and with sprinklers in almost all high-density buildings, that's why those improvements have been so important. However, we can never be complacent, particularly here in developed countries. I mean, despite these improvements to making these buildings more fire resistant, developed countries are still not immune to deadly fires and high-density housing and occupational structures. And we don't have to go back very far in history to see this. Just back in 2017 in West London, United Kingdom, the Grenfell Tower caught on fire. It ultimately resulted in 72 deaths. What happened in this case was that a cladding had been put on this building. A cladding that was designed to sort of reflect sunlight away and help with energy savings. But this cladding was not sufficiently fire resistant, and so when some building contents ignited in one of the apartments near one of the windows, that cladding very rapidly caught on fire. The cladding fire rapidly raced up the building and engaged more building contents, and next thing you know, a bunch of people had to evacuate a very tall building very quickly, and unfortunately 72 of them did not make it. So despite the improvements that have happened in developed countries, these kind of things can still happen if we're not continuously vigilant. When structural fires are investigated, the risk factors that lead to most of them are listed on this slide. At the top we have the risk factors that occur within the structure. At the bottom are some risk factors outside the structure that can still impact the risk of structural fires. One of the largest risks is unsupervised children. Children, particularly when they between ages of about 4 to 9, are at a very curious phase where they are really exploring their surroundings a lot. This is when a lot of times kids first get their hands on matches or fireworks or lots of other lighters, things that they really shouldn't be getting their hands on. So if children are unsupervised with potential ignition sources, this is how a lot of structural fires start. Really, candles are open flames of all types, even when adults are handling them. I mean, with a candle or a fireplace or something like that, you literally have a fire in your house, and it's a fire that can very easily ignite contents around it if that fire is not kept within the firebox, or if the candle's not kept upright. If a candle falls over, many of the things that it can fall onto are things that it can easily ignite. Again, you've got a very, very intense source of heat and some materials with relatively low ignition temperatures, and that's how a lot of this happens. The same with indoor smoking. The tip of a cigarette is more than hot enough to ignite many building contents if the smoking materials are not carefully handled, or if people pass out or fall asleep or become unconscious while they're smoking and the cigarette falls out of their mouth. That's a source of a lot of structural fires. Heat generating appliances and equipment are another risk factor. A lot of times a heat generating appliance such as a stove, they're designed to heat food, for example, up to a temperature to make it safe to eat, to kill off the bacteria and actually prepare the food. And that's good, but sometimes if they're not regulated properly, they can actually, again, ignite the food, which is not something most of us ever want to see happen, but also can ignite other contents and lead to a building fire. And other heat generating equipment, such as space heaters that don't have proper tip-over protection, can do the same thing. Anytime you have a house that has outdated wiring or overloaded circuits, both of these can readily spark. And a spark, again, there can be enough heat in a spark to ignite building materials and start a structural fire. One that we might not think about as much as we should is holiday decorations. For various holidays, people like to put up lights in order to maybe brighten up a space and make it seem more festive. Holiday decorations are usually designed just for short-term usage. They don't often have as high quality of insulation on them as like more permanent decorations would, and so therefore they can ignite building contents and be a source of fire. I talked before about gas leaks, how if you have natural gas in your home, that can readily ignite if it's not managed properly or if there's an earthquake or some other event. A lot of times a house will also have a garage attached to it. Either maybe the first floor will be a garage or there will be an attached garage on the side. And then you have to consider how things that happen inside the garage can burn the whole structure. Biggest example of this would be if you have a car that due to a fuel leak gets an engine fire. If it's parked in your garage and your garage starts to catch on fire and the garage is attached to your house, well, now you have an occupied structural fire as well. So vehicle maintenance, is an important risk factor for structural fires if you have an attached garage. At the bottom, these are factors that are not inside the structure itself, but that can easily impact the structure, as we saw in Lahaina and in Paradise. Certainly weather patterns, forestry practices, and having dry vegetation near your house, not having what we call defensible space around your house. These are all examples of how wildfires or fires that start outside of a house can quickly impact a house. Because wildfires can burn houses in the woods and near the urban-wildland interface. And as I said before, as climate change becomes more of an issue, and this persistent drought we have here in the west and southwest causes more vegetation to be fuel for fires, these are the types of risk factors for structural fires we must consider. So like every other injury topic we've talked about this semester, if we want to prevent deaths and injuries from structural fires, we can start at the primary level. And primary prevention would be there's never a fire, so the structure never becomes engulfed in fire. So in this case, we'd be talking about preventing the three legs of the fire triangle from coming together. We'll talk a little bit more about that shortly, some ways that we can do that. A very important thing to consider for structural fires, though, are secondary preventions. These can save a lot of lives, where maybe the initial ignition occurs, a fire develops, but then we have measures to stop or slow the fire at a vulnerable point, at its incipient stage, so that it doesn't get big enough to really cause the kind of harm and mass casualty event that we've talked about already in this lecture. So that would be a mitigation thing. And also, sometimes fires can't be prevented, or even they can be mitigated but not completely slowed. In that case, what we need to do is train people on how to respond and how to evacuate. A lot of times fires move slow enough that if people are given adequate notice through an alarm system, through other means, and actually training on what to do, they can actually get out of the structure before the structural fire impacts them. So secondary prevention is so important. And I'm not going to talk about tertiary too much, but it is very important. It's great to have rapid and effective medical response to deal with burn injuries and smoke inhalation and other negative things that happen when people are injured by fire. Again, fires, injuries are so debilitating and so painful, they can, even when people survive them, they can cause lifelong traumas and loss of function. So We're not going to talk anymore about tertiary measures. We're going to talk a lot about secondary and primary preventions because we never want people to get burned. We'll start with primary prevention strategies. In this case, our goal is to prevent a structural fire or a wildfire, because as I talked about before, wildfires can often impact structures. We want to stop these fires from ever occurring so that no persons are injured. If we want to do primary prevention, 2 of the 3 legs of the fire triangle are realistic targets. If we're talking about preventing a fire inside an occupied building or in a forest, we can focus on fuel, we can focus on heat. The 3rd leg, oxygen, there's only very specific and limited instances where suppression of oxygen is a realistic or desirable goal, and because again, humans need oxygen to survive, but the other 2 legs, fuel and heat, are much more realistic targets for primary fire prevention, and so we'll talk about those in a little more detail now. One of the most basic primary prevention strategies for fire is to make buildings more fire resistant through construction techniques. Throughout the 1900s, one of the most common techniques within schools in particular, but also in other high-density buildings, was to use asbestos, a mineral silicate that is one of the most fire-resistant substances known to mankind. And you would put asbestos into schools and into other buildings, and it became exceedingly hard for the basic structure of the building to catch on fire. Unfortunately, there were some other problems with asbestos that we found out in ensuing decades, that as asbestos degrades, some of the small particles as they become friable, meaning that they crumble off, some of the small particles can become airborne, and if you breathe asbestos fibers, there's some severe respiratory hazards that can result. Asbestos exposure is a risk factor for asbestosis, a fibrotic lung disease where the lungs become stiff and gas exchange can no longer occur. Asbestos exposure is also a risk factor for lung cancer and also mesothelioma, which is a cancer of the pleural lining around the lungs and other organs of the chest. So because of this, in 1990, asbestos was banned from all new U.S. constructions. There's still plenty of asbestos in older buildings. It's generally managed in place now and kept encapsulated so that it still has the same fire resistance it always did, but it's managed in such a way that it does not degrade to create a respiratory hazard. In the ensuing decades, there have been many other building materials that have been developed that have just about as good a fire resistance as asbestos, but they don't have the same respiratory hazards. And so now the goal is to build and furnish new homes and offices with these materials that do not readily function as fuel for fires. Some examples of this would be structural materials. To the extent that it can be, wood is often being replaced, especially for outer cladding, with things such as brick, stucco, concrete, and gypsum, which is generally pressed into these boards that we call drywall. Now, these materials, they can catch on fire. They do have an ignition temperature. It's just a much, much higher ignition temperature than there is for wood. So therefore, if you have these structural materials, even if you have wood studs inside the wall, the materials on the outside do not readily conduct fire, and so the building can be exposed to a lot greater heat before it starts to catch fire if you use these type of structural materials. One of the lessons of the Great Chicago Fire was that fire-resistant roof materials are so important. We now have what's called Class A fire-resistant roof materials. We see these a lot in the Las Vegas Valley, where you see concrete or clay tiles on roofs, where there'll be fiberglass asphalt shingles rather than coal tar asphalt shingles, which have the fiberglass has a much higher fire resistance rating. So what these materials do is if you have an ember that falls onto your roof as a result of a wildfire, or if lightning strikes your roof or something like that, they're not going to readily ignite and then propagate a fire very easily. Now, a lot of houses will still have wood trusses underneath the roof that, if an ember or a lightning strike gets to them, yes, those more readily ignite. But having a roof cladding that's fire resistant can prevent a lot of the rapid structure-to-structure fires that result in whole entire whole entire municipal blocks catching on fire. And of course, the contents of buildings now. We have rugs, carpets, floor coverings that are now a lot more fire resistant than they were maybe 100 years ago. If you went back in time 100 years and you were a smoker and you were sitting on a couch or some other piece of upholstery or laying on the ground with some carpet and you fell asleep and that cigarette fell out of your mouth, there was a pretty good chance that carpet or those pillows or those drapes or that upholstery was going to rapidly catch fire. And if you were not roused from your sleep quickly enough, you would likely suffer a severe burn or maybe even a fatal one. Now there's materials are a lot more fire resistant than they used to be. You still want to be careful with smoking materials and other sources of ignition indoors, but these materials don't propagate fire to the extent that they did in previous centuries. Another primary strategy would be to prevent heat sources from igniting building contents, and there's many ways you can do this. Certainly by not leaving smoking materials or candles unattended indoors. That would be a big way of preventing fires from occurring. Also, just ensuring that all house wiring is up to code and that no circuits are overloaded. This happens a lot of times when people add on to a house and they don't really think about how to wire up the new addition. They just tap into an existing circuit, not thinking about things like total load, and maybe don't get a licensed electrician involved when they should. I mean, that's one way to prevent this sort of ignition from happening. Flame-free cooking appliances can also prevent a lot of fires, but I'm talking about things like electric ranges rather than gas ones, because a gas stove or a gas range, you actually literally have a fire, and for a gas stovetop, yeah, you have a literal fire on top of the stove that you then use for cooking food. And a flame-free cooking appliance is a lot less likely to burn anything around it. If you can keep flammable chemicals and fuels away from residential areas in detached garages or outbuildings, that's a great primary prevention strategy. Something I would encourage you all to do is if you ever are in the market to buy a house or you're needing to rent a piece of property, if you can get one that's got a detached garage, that can prevent a lot of fire risk, because keeping your chainsaw, lawn mowers, or even your entire vehicles separated from your actual residential building so that if any of those things catch fire, it doesn't immediately also engage the residential structure where you live and sleep. That's a good thing. Lightning rods are an important thing to have if you're in an area where a lot of electrical storms occur, because a lightning bolt can reach several thousand degrees Fahrenheit. When it strikes a roof or some other building materials, it can instantly ignite it. And a lightning rod will actually draw the lightning so that it does not strike the roof. It'll strike the metal rod instead and have a path to ground. So the lightning rods are a very important prevention strategy, as I talked about before, seismic valves on gas lines, so that in the event of an earthquake that ruptures a natural gas line, the gas immediately goes off and doesn't cause that building to fill with gas, where then a simple spark or a little bit of friction can ignite the gas and cause a major explosion. In the occupational and environmental health and safety world, there are actually some regulatory programs that serve a primary prevention purpose as well. They can help prevent catastrophic fire and explosion incidents in facilities that can then also impact communities if they occur. And if we can stop them from occurring, nobody gets impacted. We're going to talk about EPCRA, the Emergency Planning and Community Right to Know Act. That is covered extensively in the Role of Emergency Planning and Preparedness lecture, so I won't talk about it anymore here. The Occupational Safety and Health Administration has something called the Process Safety Management Standards, where if you have a facility where certain high hazard chemicals are used, there are 14 discrete elements of process safety that have to be in place, and they have to be in place and well documented and done every single time. You have to do process hazard analyses to make sure that of all foreseeable uses of this chemical or other high hazard thing, that things are not going to go wrong. There has to be a pre-startup safety review before you start a new process or change a process involving one of these highly hazardous chemicals. There has to be management of change. In other words, if you're using this highly hazardous chemical, no matter where you're using it, let's say you've got like a tank or two tanks that use this chemical with a line that connects them, and you want to change out that line with something that's slightly different. You have to do a lot of research, a lot of engineering design. You have to basically think about every single contingency before you implement that change. That change has to be managed. And I won't go into all 14 managed elements of process safety management, but it's really important because when the chemical facility in a neighborhood suddenly explodes because process safety management principles were not followed, it can very rapidly impact not just the workers, but the people who live near the plant. So it's very important for those reasons. The Environmental Protection Agency has a very similar rule called the Risk Management Plan Rule that has really a lot of the same elements as process safety management, but instead of applying to a workplace setting, they apply more to the setting around the workplace and the community impacts of these activities. Another example would be the Chemical Facility Anti-Terrorism Standards, or CFATS. These come from the Department of Homeland Security. If you're a facility that has a certain chemical of interest above a certain quantity, like for example ammonium nitrate, the chemical that caused the devastating Texas City explosion in 1947 I talked about earlier, you have to have plans in place for how you're going to secure that chemical, for how you're going to make sure that chemical does not degrade or cause a explosion hazard. And also you're going to have plans for how to protect that chemical, to have security so that terrorists or other people with ill intent can't go in and steal it. So these are very important regulatory programs that really prevent major fire and explosion things from ever occurring in the first place. Some wildfire-specific primary prevention strategies include the following. Better forestry management practices. This can reduce fuel load, particularly in drought-stricken areas like we have here in the western and southwestern United States. Sometimes because of inadequate staffing or inadequate budgets, federal forest lands and even state-managed forest lands don't get the attention they need in terms of cutting back some of the undergrowths and some of the fuels that build up on the floors of a forest. And when these things are not adequately cleaned through prescribed burns, through other clearing techniques, when a wildfire does occur, it can rapidly spread and it can burn a lot hotter than it normally would. It can even burn hot enough to actually affect and even kill the older growth that under normal circumstances of prescribed burns or would not be affected, but with the new hotter fires because of all this fuel underneath, they actually can be affected and they can die. And unfortunately, in some of the iconic national parks of the West, including Kings Canyon and Sequoia National Parks, a lot of the old growth sequoias were killed by a recent wildfire event because the fuel load underneath them was not managed well enough. And also just keeping non-native and invasive species out of plants, particularly grass and shrub species, out of forested and other lands can help reduce wildfire load as well. Just using common sense with things like campfires, fireworks, target shooting, and smoking materials when you're out in woodlands and grasslands and things like that. Make sure to obey red flag warnings. Don't have a campfire if it's a red flag fire warning day. Don't shoot off fireworks. Target shooting, you just have to exhibit common sense, which unfortunately is not always as common as it should be. It wasn't that long ago, just a few years ago, there was a massive wildfire that occurred down in San Bernardino County across several acres of grasslands where a couple was doing a gender reveal party where they would shoot at tannerite targets and the targets would explode either blue or pink to indicate the gender of the baby. Well, the tannerite targets, when they exploded, they ignited some grasslands, some really dry grass, and caused a multi-acre fire. And they were fined a significant amount by the county when it was revealed that their poor planning had caused this pretty extensive grasslands fire. If you're driving a vehicle in woodland areas or in grasslands or shrublands, make sure not to park over dry grass or other dry vegetation because the underside of a vehicle gets very hot. It can very easily ignite these contents, and then if that happens sometimes and the fire's not put out quickly, that can spread to the vehicle itself, and the vehicle can catch on fire. Make sure if you're towing something to not drag trailer chains, because dragging trailer chains can produce sparks which can easily ignite vegetation along a roadside. Spark arresters are important because whether it's a on-road vehicle, off-road vehicle, a dirt bike, an ATV, whatever it is, incomplete combustion can often shoot sparks out the tailpipe of a vehicle, which can easily ignite these materials, but a spark arrestor will prevent that from happening. Now let's move on to secondary prevention strategies for fire. In this case, we didn't stop the initial ignition from occurring. Some fuels were heated above their ignition temperature, and they ignited, and so we have a fire. But once we have a fire, that's not the end of the story. Our first goal will be to stop the fire at an incipient stage before major injuries can occur, or major structural damage, which of course can also lead to injuries. So that's the first goal of secondary prevention. An alternate goal, though, is to safely evacuate all persons before the fires can cause injuries. If a fire occurs but everybody gets out before it can impact them and no injuries occur, yeah, you still get property damage, but you don't get loss of life or injuries. So these are both secondary prevention strategy goals. For secondary prevention, there's a significant role to be played for engineering controls, safety equipment, personal protective equipment, and training. Engineering controls and safety equipment can help people get notified early that a fire event is occurring so they can then start the evacuation procedures. Personal protective equipment can help people to fight a fire or to escape a fire without getting burned. And training, of course, can let people know when the alarms are going off or when they get some other form of notification that a fire event is occurring, that they'll know where to go, how to do it, where to assemble, all the little elements that make a evacuation a lot more successful. One of the most important secondary prevention strategies, and one of the most important pieces of safety equipment that a lot of buildings have now, are automatic fire suppression systems, more commonly known as sprinkler systems. These were tragically absent from the MGM Grand back in 1980, that event I talked about earlier here in the Las Vegas Valley, that resulted in several deaths. Automatic fire suppression systems can work in a few different ways. The most basic fire suppression or sprinkler systems work to wet the fuel. As you wet fuel, you raise its ignition temperature to a point where it doesn't burn as easily. It can slow down and even stop a fire. What you see here on the left is a depiction of a sprinkler head. It's got a little thing called a fusible link that at a certain temperature is designed to melt, and it's not a very particularly high temperature. Once that is reached and that melts, then water starts flowing into the sprinkler head, and then the design of the sprinkler head kind of broadcasts that water around a certain footprint so that all the fuel beneath it is wetted. Of course, this also causes property damage because you have building contents that are getting wetted, but the thinking is with sprinkler systems is that you, by wetting this fuel, you slow down fires so they're not as prone to fire, and of course, if the building burns slower because of sprinkler systems, that gives people a chance to get out, and so it reduces the chance of tragic loss of life or severe injuries. Another way that an automatic fire suppression system can work is by cooling the heat. This is something you see often in commercial kitchens, where you'll have a system designed to, when it senses an elevated temperature that's not supposed to be like above the normal temperatures you get off of a cooktop, it will actually spray this foam, which we'll talk about a little bit later on, Class K foam, that will actually chemically react with the grease, with the other materials that are on fire, and immediately cool them down and stop the burning process. Third leg of the fire triangle is oxygen. There are some very limited uses for suppression of oxygen. Usually it's only in indoor environments that have high value equipment such as servers or a lot of computers or things like that, where you don't necessarily want a traditional sprinkler system to be in play here because it would damage or destroy a lot of very sensitive equipment. So in this case, you have usually a nitrogen-based chemical that is quickly pumped into a room whenever a fire is sensed, and then the nitrogen chemical expands very quickly, pushes out oxygen, and snuffs out the fire. Of course, these systems, when they're in use, have to be done with extensive training of personnel so that people know when the alarm goes off, they need to evacuate immediately, not just because there's a fire, but also because there will not be enough oxygen in this room to sustain life very quickly once these nitrogen-based chemicals such as halon start being sprayed in there. So there's a very limited use for suppression of oxygen, pretty much only in indoor environments. There's no real feasible way of doing this in an outdoor environment, such as trying to put out a wildfire, but that's the very limited use for suppression of oxygen systems. Another important piece of safety equipment for secondary prevention of fires are handheld fire extinguishers. These are often strategically located in most office and educational buildings, including here at UNLV. You can find handheld fire extinguishers, and maybe they won't be in every single classroom, but they certainly will be in every building. Again, strategically located. Important thing about handheld fire extinguishers is that they're good for fighting fires at incipient stages. They're not necessarily good at putting out a structural fire. They're not designed for that. Let's talk quickly about the classes of handheld fire extinguisher. These categories come from the National Fire Protection Association, and you'll see these on the sides of any fire extinguisher. So you'll know what type of extinguisher it is and what kind of fire it's good for. Class A extinguishers are good for putting out wood, paper, textiles, and other rubbish, sort of traditional ignited materials. Class B fire extinguishers are good for putting out flammable liquid fires. And Class C fire extinguishers are good for putting out energized electrical equipment that is caught on fire because of a short or some other electrical failure. Now, here at UNLV, and really in a lot of places you go, Class A, B, and C will often be combined into one extinguisher, the Class ABC dry chemical extinguisher. We have those everywhere here on campus. They can put out liquid fires, electrical equipment fires, and traditional wood, paper, and textile fires. In some places at UNLV, you will still see just Class A only extinguishers. These are big extinguishers that just contain pressurized water. They're really only good for, again, wood, paper, and textile fires, but most of the ones you see here at UNLV will be Class ABC dry chemical extinguishers. There's another category of extinguishers called Class D. These are good for putting out combustible metal fires. You get fires on metals such as magnesium or lithium. They burn very intensely. It is very hard to put them out with a traditional water extinguisher or even a traditional dry chemical extinguisher. That's why Class D extinguishers are so important for things such as lithium battery fires. Another class of extinguisher that's becoming more common now is Class K extinguishers. These are a foam that is especially good for putting out fat and grease fires, particularly in cooking environments. They work a little bit better than the Class ABC extinguishers do for this purpose. They work on a process known as saponification, where you actually spray, these materials are sprayed from a handheld extinguisher, or like I said before in the previous slides, from a fixed extinguishment system, and this foam will immediately react with grease and other materials that are on fire in a cooking environment and immediately cool them down, kind of, again, through saponification, kind of turn the materials into a soap and snuff out the fire immediately. So these are categories of extinguisher that you might encounter here at UNLV or other places you go. One of the principal limitations of handheld fire extinguishers is that if you want to use one and use it effectively, you have to be in proximity to the fire because they don't shoot all the way across the room. You kind of have to get close to the fire in order to put them out with a handheld extinguisher. This is why you must always remember that handheld extinguishers are for incipient stage fires only. If a fire catches in like a microwave or a trash can or something like that, you can grab an extinguisher and put it out, but only if it's incipient stage. If structural contents of a building are starting to catch on fire, like it's spreading up a wall or something like that, now it's too big to deal with an extinguisher, and you need to be evacuating instead. If you want to use a handheld extinguisher to put out an incipient stage fire, remember the important acronym PASS. First thing you want to do is pull the pin out of the handle. Most extinguishers have a little pin in them to keep them from being discharged prematurely. You actually have to actively pull the pin out before you can squeeze the nozzle or the trigger and get any fire-resisting chemicals to come out of the extinguisher. So first thing is pull the pin, that's P. Then A is aim. You aim the nozzle of the extinguisher at the base of the fire, not at the tip of the fire. You want to aim at the base of the fire because that's where you want to spray the chemicals or the water or whatever it is that's in the extinguisher. So you aim, then you squeeze the lever or trigger slowly to begin to release some of the fire extinguishment contents out of the extinguisher. And then you sweep from side to side, all along the base of the fire until there is either no more fire or until the fire extinguisher is emptied. So pull, aim, squeeze, sweep. That's how you use a fire extinguisher. It's only for incipient stage fires. Having a fire extinguisher does not make you a structural firefighter. Some examples of additional engineering controls that make successful building evacuations more likely include the following, and probably most importantly, operational smoke and heat detectors. These can give people lots of advance warning that there's elevated levels of heat or smoke in the building, and that even if you have mobility issues, they're usually designed when they're operational to give you enough advance warning that you can get out of the building before the situation escalates to deadly amounts of smoke or deadly amounts of heat. Now the key word there is operational. A lot of times smoke and heat detectors will be battery powered, and if the batteries are not routinely changed on them, then the detectors might not do what they're designed to do when it's needed for them to do that. For those of you that rent, I will say that if the building owners are not doing proper maintenance on smoke and heat detectors, raise a fuss about it. You deserve to have these types of devices working in buildings, and in fact, building owners and operators that make rental units available for tenants are required by law to provide these. So speak up if this is an issue in a building that you're occupying. There are other early warning alarm systems that occur sometimes. They're hardwired systems that have annunciator panels used in conjunction with code words and things like that, so that there can be a quick announcement put out to a certain sector of a building that an evacuation needs to take place. These happen a lot in places like hospitals where you don't want the entire hospital to be notified when a fire is broken out because you don't want the whole hospital evacuated. That can be a very dangerous and traumatic thing to do, especially to vulnerable populations. And if you're in a part of the building that is not impacted, you don't want those people to be disturbed. So a lot of times early warning alarm systems that are sector-based and with annunciator panels and code words are very useful for selectively evacuating part of a building. Fire-resistant egress corridors are one of the most important things that any building will have. These are corridors, usually at the ends of a hall, that are designed to be the escape routes. Now, the way that these corridors work is that, they will have usually a 2-hour fire-rated door on them that will hopefully be self-closing so that when the fire alarm starts to go off, they automatically close. But it's really important if you have a building with these fire-resistant egress corridors, they're designed to be a place of refuge in the event that a person cannot completely escape the building. They can have at least a couple of hours of refuge in this area before the entire building burns down around them. But this only works if the doors are kept closed. So if you're in a building that has these fire exits like you see depicted here, make sure these are not propped open with plants or with other objects that would keep them from self-closing in the event that they need to self-close. Because the egress corridor only works if the doors are kept closed. Emergency lighting is another very important engineering control because often when a fire occurs in an electrical area or you just get a fire where a lot of smoke comes in, it can be difficult to see and find your way out. So these emergency lights that come on either when the power goes out or when the fire alarms go off can be very critical to helping people find their path to escape. Sometimes you need additional means of egress, particularly on very wide buildings where the egress corridors are relatively spaced far apart, sometimes the fire will be between you and the egress corridor, and you need another way of getting out. This is where strategically placed fire ladders, like you see here, would be handy, where somebody can open or break a window, deploy the fire ladder, and climb down the building. This is not something you want people routinely doing, because there's plenty of potential hazards in doing it. But if you cannot use the traditional egress corridor and you need a way to get out before being overcome by fire or smoke, yeah, fire ladders work great. Other important secondary prevention strategies for structural fires include regular training and drills. And the importance of these drills is, again, get people to recognize when the alarm goes off, what they're supposed to do and where they're supposed to go. And where you're supposed to go is really important, because you want to be able to account for everyone that's in a building. Certainly if it's an occupational setting or a residential setting such as a dormitory. You want to be able to tell the local fire department that looks like everybody that was supposed to be in there is now out here and accounted for, or maybe there's a few people that we think should be out here, but they might still be in there. So that's why having a system of head count is very important as part of your regular training and drills. Of course, all regular training and drills must consider those with mobility issues. And really, the whole point of the training and drills is to make sure that the most vulnerable people within a building, whether it's residential, occupational, whatever the case might be, that they are accounted for, that they are evacuated, that they are protected. And so there needs to be consideration of all these things when the training and drills occur. And no matter how often the drills occur, I know sometimes they get a little repetitious, but take them seriously. They could save your life, and they're a very important secondary prevention strategy. For strategically placed equipment, I already talked about fire ladders, but also strategically placed fire blankets can be of use. A fire blanket can actually allow a person, if they need to be able to roll through a wall of fire in order to get to an escape corridor or something if there's fire between you and it. And of course, having a well-trained and equipped fire department nearby that's trained on search and rescue, that's trained on fire extinguishment, and that also is familiar with the actual contents of the building, especially if it's an occupational building that has a lot of hazardous chemicals. And this is something that's going to be covered in the emergency planning and preparedness lecture as well, that making sure that fire departments are actually notified of special unique hazards that might exist in a building that might determine how they try to fight the fire. When we talk about secondary prevention strategies for wildfires, we have to acknowledge that in this case, we're not just talking about one house or one structure that needs to be evacuated. We're talking about a situation where a whole community might need to be evacuated, and maybe evacuated very quickly. Many of the tragic loss of life that occurred in Paradise, California, and Lahaina, Maui, Hawaii, were due to the fact that the community was not evacuated in time, and a lot of the escape paths were quickly engulfed in flames. So one of the most important things to do is plan for these events before they happen. And sometimes community planning, if you're in a really fire vulnerable region, such as right on the edge of the urban wildland interface, some of this planning might have to be some realistic assessment of, okay, if this happens, what are we going to do? And part of that might be, you might need to start thinking about additional means of egress. I mean, the problem in Paradise, California was that most of the ways of getting out of town went right through the areas that were on fire. And so part of sensible urban planning is making sure that there's more than one way in and out of a town in the event that something bad like this happens. There also needs to be planning for what to do for if an evacuation does occur. What are you going to do about the most vulnerable people? Not just people with like mobility issues, or maybe people that don't own a car, but people that maybe don't have the means to go to a neighboring community and stay in a hotel for several days while a situation resolves itself. A lot of times what happens in a community is that these vulnerable people wind up staying in the danger zone because they've got no other options. That creates a major social justice issue, and and a major injury risk. So part of community planning, you have to consider this as well. Certainly early warning systems, if they can have the community notified as early as possible that situations are unfolding. Not even just like a fire that's occurring, but even that conditions are right for fire. Like if it's like what happens with red flag warning conditions, or when you know that there's going to be really stiff winds or something like that. Then of course training, drills, equipment, these are all important to make sure that a community can evacuate when it needs to evacuate. At a personal level, it's really important if you are living on a property, particularly one that's in the urban wildland interface, to create what's called defensible space around a property. You know, trees are fuel for fires, and so you want to make sure not to have trees coming right up to the house line, because that brings fuel a lot closer. You might need to have a 30 or even 50-foot zone cleared around the house where there are no readily combustible trees, where maybe you have more drought-tolerant landscaping or hardscaping or things like that. This is why a lot of times you can have a wildfire that rips through an area and burns an entire forest, but there will be a house or two left in the middle of it that are relatively unscathed. That's because of adequate defensible space was created, along with what I've talked about before with the fire-resistant building construction, because even if you have a 50-foot zone of no trees around a property, if a wildfire is occurring, there's going to be embers flying around everywhere. And some of these are bound to hit the house, land on the roof. But if the roof is made of a relatively fire-resistant construction, it might take quite a while before you actually get engagement of fire on that structure. Maybe even possibly long enough for the fire to burn itself out around and not impact the structure. So that's what we mean when we say creating defensible space around properties. Some of the important points I wanted you to glean from the Al-Haj and colleagues article that was assigned in this week's module are the following. This should come as no surprise to you that residential fires disproportionately affect vulnerable communities. And there was a number of reasons why the authors believe this to be so, and not just believe it, but evidence shows this as well. One is that there tends to be much higher residential and occupational building density in some vulnerable communities, which leads to crowded conditions. Sometimes there's a lot of older homes that maybe are not built with modern fire-resistant construction techniques. There's often a lack of primary or secondary controls. People don't have fire extinguishers or working smoke alarm and heat detector systems, so that there's these type of controls that would normally stop a fire at an early stage or stop it from ever happening in the first place are not there, and also limited tertiary care. Burn injuries leave people vulnerable to infections and to a lot of other very bad health outcomes, and when there's not tertiary care, people will often die from burn injuries. So these are some of the reasons why there's disproportionate vulnerable community impact from fires. So what works in these communities? Well, a combination of education plus low-cost safety equipment has been shown to work. And this should be very, very obvious, but when you provide low-cost safety equipment such as fire alarm systems and education on how it works and how to maintain it, that can make a very large difference, as can installing smoke alarms in spaces and doing sprinkler inspections. Now, obviously, not all buildings are going to have sprinklers. Even in the Western world, it's unusual for single-family homes, for example, to have a sprinkler system. But in occupational settings and in multi-unit residential complexes, such as apartments and condos, there are sprinkler systems present a lot more often. But if they're present, they need to be regularly inspected to make sure that they'll actually do what they need to do when they need to do them. The 4 E's of engineering, education, enforcement, and environment plus engagement really works well to reduce community injury risk in these vulnerable communities, but making sure that the engagement is culturally appropriate. You know, for some cultures you might have to change your fire safety education to fit the cultural sensibilities of wherever you are, and if you're going to be a global injury prevention professional, that's just something you've always got to keep in mind. So in summary, fires are still a major injury hazard and a persistent injury issue. It's a major hazard in many developing nations, but it's still a major injury hazard here in the United States as well, where it's still the 13th leading cause of injury death. Now, it's not borne equally across all areas of the age spectrum. The greatest risks are in those under the age of 4 and greater than the age of 65. We have to acknowledge, though, that the fire risk is not necessarily getting less in the U.S., and in fact, it might become worse as the years go by because wildfire risk is appearing to increase with climate change, and many communities, particularly those that are in the urban-woodland interfaces, are very vulnerable to wildfires that then engage structures and that then possibly risk the safety and health of people. What we do know is that primary and secondary preventions can reduce the likelihood of an unplanned fire occurring, and then when an unplanned fire does occur, it can help people to escape and survive. So that's it for this week's module. Let me know if you have any questions or concerns. Thanks for your attention today.